Next we're going to do cosecant and secant. Okay, so let's take a look at what they would look like. Well, y equals cosecant theta, and cosecant equals 1 over sine theta. This is just the reciprocal of this. So if we can graph sine theta, I'm just going to roughly graph it here. Okay, so there's 2 pi, pi over 2, and 3 pi over 2 approximately. So sine is, if there's 1 and negative 1, if that's sine theta, then the reciprocal of that, well, anything that's on the bottom is going to be a vertical asymptote. So I'm going to have that vertical asymptote. I'm going to have that vertical asymptote. Okay, so when that is 0, I got a vertical asymptote. So sine theta is 0 at 0, pi, and 2 pi. So now we're going to do 1 over the y values of sine. So 1 over 0, well, that's undefined. So just slightly over, 1 over these small values is going to be really big. 1 over 1 is 1. 1 over negative 1 is negative 1. 1 over small values is big. So we get this, just like when we did reciprocal functions with polynomials, we get these functions here. So that's cosecant. Secant is very similar. Secant is 1 over cos. So you do the same thing. Graph cosine theta. Okay. And now we're going to have, for secant, we're going to have vertical asymptotes here and here. Wherever cosine was 0, we're going to have vertical asymptotes for secant. And then this just becomes like this, that, and that. Okay? So the green one here is secant theta. And now for cotan theta. Well, cotan y equals cotan theta, which equals 1 over tan. So again, draw tan theta, and okay, so there's pi, 2 pi, pi over 2. And now we just have new vertical asymptotes wherever tan equals 0. There's our new ones. And here. And then it just ends up being a little different. Okay, so looks like that. Looks like that. Like that. So cotan theta is this green function here. 1 over small values is big. Okay, 1 over itself. 1 over 1 is 1, and so on. Okay, so that would be the cotan graph.